Greetings, math fans. All right, so this is day 2 of vectors, and we spent the first day talking more of like drawing some of the vectors, learning tip of tail and parallelogram method, etc. And now what we're going to do is we're going to do some more algebraic vectors. So let's kind of review a few things here. So I want you to remember a vector has an initial point and a terminal point. Okay, and basically what we're going to do now is, because remember the initial point is the tail of the vector, and the terminal point is the tip of the vector. All right, if I would kind of just make a quick sketch here, right? That's your tail, that's your initial point, and that's where it's ending, your terminal point, and the end of the arrow. Okay, now what we're going to do is we're going to actually use a rectangular coordinate plane. So using a rectangular coordinate plane, so it's just like having an XY axis. The initial point is going to be, is at the origin, which is basically 0, 0. Okay, and when we're using this method now, having the your initial point at the origin, we call this is called a position vector. Okay, so basically, if x comma y is the endpoint, so it's our terminal point, this is what it would look like. You would have, again, this is 0, 0. That's your initial point, and xy is going to be your endpoint. So this is basically, this is x comma y. That's going to produce your vector. Okay, pretty simple. So just cursor down here a little bit. The vector is written, so we have a special notation to show this. Okay, but the vector is written as, and these are vector brackets, x comma y. So just like a coordinate, except it's not really a coordinate, it's now a vector. Because if I just said x comma y, that would be a point, and you'd point to the point. But if you see x comma y in vector brackets, that is actually a vector. So it's starting at 0, 0, going to that point, and it's a ray basically going to the xy coordinate. Okay, please do not forget those vector brackets. And they're basically a vector bracket. You kind of remember that because if you look at, turn it one way or turn it another way, looks like a V, right, for vector. And of course, I use x and y because that's our x component, and of course that's our y component. Sometimes you might see it in books where they call it a and b. I just like to use x and y because then you just know exactly what it is. So if I actually would create a vector, this vector then would be x comma y, and I would know it starts at 0, 0. Okay, and this is our vector u, and this is our vector theta, or our angle theta. Okay, direction angle. So let's actually talk about those two different things. I'm going to cursor down a little bit more. Using this picture here, we have the magnitude of, magnitude, of course, is length, right? Magnitude of u. Okay, and we can write that using our little notation. Remember we talked about this already. That does not represent absolute value, it represents magnitude. And so basically the magnitude, just think about it. If I look at this picture, this is x and this is y, right? Is it just Pythagorean theorem? That's all it is. So it's a squared plus b squared equals c squared, and then so we say the magnitude of u is the square root of x squared plus y squared. Very simple. All right, direction angle. Which is our theta, it's basically a positive angle between the positive x-axis and the vector. Okay, so this is how we figure that out. Let's keep going here. I'm not going to put tangent of theta is equal to y over x, even though I just wrote that. It's actually, this is really important. I'm going to put it in red here, but it's actually tangent of theta prime. Okay, and these are, I hate to actually put absolute value brackets around here because I don't want you to get confused between absolute value and magnitude, but I'm just going to say these are both positive values. Okay, so it's both positive because what happens is when you do inverse tangent on your calculator, if one of them is negative, it's going to give you basically a negative answer, and then you're going to be confused on what to do. So if you use positive values no matter where it's located, okay, no matter where it's located, your vector, you're going to get a reference angle, and then if you guys remember, this is from back in the day, right? If it's in this quadrant, it's just theta prime. If I give you the reference angle and it's in the second quadrant, it's going to be 180 minus theta prime, and this one's going to be 180 plus theta prime, and this is going to be 360 minus theta prime. Okay, this is like the old days, me handing you a reference angle and telling you what quadrant it's in, and you know what to do. Either subtract from or add to 180, or subtract from 360, or just the reference angle. Okay, and remember this guy right here. Of course, it's just the ox, our good friend the ox. All right. So again, this is really, really important. These need to be both positive values, the y and the x, to get that to get your reference angle. Okay. So let's do an example. How exciting! All right. So I'm going to clear this out here now. The example is going to say find the magnitude and direction angle of -3, -4. So again, I know it's a vector because I see the vector brackets. Okay, so to find, we'll call this vector u. U is a nice little, just an easy way to refer to it as. Okay, but the magnitude of vector u is the square root of, now you could say -3 squared plus -4 squared, but you know it's going to be positive anyway, so why put the negative in there? And in fact, I would recommend not even putting the negative, because what happens if you put the negative in and you forget to put in parentheses, you're going to get something negative, and you know negative squared should be positive. So just do 3 squared plus 4 squared. So if you already recognize this is a 3, 4, 5, right? Triangle. So it is equal to 5. So the magnitude's 5. Got our first part. And the next part we're going to say, hey, tangent of theta prime is equal to y over x. So positive 4 over positive 3. Again, use positive values. And we do inverse tangent, and we get theta prime. Make sure you're in degree mode, of course. It's very important. Okay, theta prime comes out to be 53.13 degrees. Now, if you put that as an answer, you're going to lose points for that because that is not correct. That is your reference angle. And where is -3, -4 located? Well, isn't it in this quadrant right here, in the third quadrant? And so what are you going to do? You're going to say, oh, well, that's just 180 plus the reference angle. So 180 plus 53.13 gives us 233.13 degrees, and that is our answer. Okay, and I even have this in my notes, math fans. Kids always forget the step. They give you this as an answer, and they don't actually give you the actual answer. They give you the reference angle. Okay, please don't forget that. Okay, you should put like a couple thousand stars around here and say, don't forget. Don't forget. Okay? All right, let's try another one here. Same directions. and it's 4, negative 6. So again, find your magnitude. Magnitude is of u is the square root of 4 squared plus 6 squared. So basically 16 plus 36 is square root of 52. And if I'm asking for an exact answer, which a lot of times I am, then it's going to be 2 root 13, right? 4 times 13 is 52, so 2 root 13. And then we do tangent of theta prime is y over x, so 6 over 4, again using positive values. We do inverse tangent, and we get 56.31 degrees. It's a reference angle. Now, where is 4, negative 6 located? Well, it is in the fourth quadrant, right over there. So we're going to do 360 minus 56.31 degrees. That gives us 303.69 degrees, and that is our answer. Okay? Really pretty simple. Not bad at all. All right. I kind of want to make a point here too. This is one vector. Okay, and the reason I'm saying this now is because we're going to get to something later on in this chapter where you're going to have two vectors, but this is one vector. Me asking you to find the direction angle for one vector. Okay, so let's keep going here. Those of you who want to be a doctor, that you want to follow along with this next part of the lesson, because if you want to be a doctor, especially a surgeon, you're going to be interested in operating on your patient, and so now we're going to study vector operations. So I'm just kidding about being a surgeon, but you probably have to know this anyway because you need to have a lot of math to be a surgeon. Anyway, the first thing I want to talk about is something called a resultant, which we already talked about this. Resultant of two vectors. And remember when we did this at the beginning of the chapter, first day, I gave you a vector and then I gave you another vector, and I said what is the resultant of the vectors, and you could do tip to tail, so that plus. So really I added these vectors together, right? So that plus that, and then remember the resultant is this guy right here with an arrow. Okay? So again, it's adding them together. So now what we're going to do is using actual vectors, algebraic vectors, we're going to do the same operation. So for example, if I gave you guys, let's clear this out of here, 2 comma 6 plus negative 4 comma 4. I'm adding those two vectors together. Okay. Now I could draw them. I mean, that would be kind of a silly thing to do. I could draw both those vectors, and do tip to tail, and then find out exactly what coordinate it is. But you don't need to do that. You basically are adding the x components together, and you're adding the y components together. It's that easy. It's so easy. Okay, so 2 plus a negative 4, so 2 minus 4 is negative 2, and 6 plus 4 is 10, and that's your answer. This is so easy. I'm going to even write easy schmeezy down here, because it is. It's easy schmeezy. All right, you can subtract too, so I can do the same thing, 2 comma 6 minus negative 4 comma 4. Just be careful what you do here. It's 2 minus a negative 4, so it's 2 plus 4, which is 6, and 6 minus 4, which is 2. Okay, just as easy. You just have to be careful when you're doing subtraction. Okay. We talked about scalar multiplication with drawing vectors, where if it was like 2 times some vector, you double the length of it. It's actually even easier when you're doing algebraic vectors, such as I'm doing here now. So let's talk about that. Scalar multiplication. So if I said 2 times 2 comma 6 plus 3 times negative 4 comma 4. Okay, basically what you're going to do is you're going to distribute the 2 in the vector and the 3 in the other vector, and then add them together. Okay, it's really simple. So we're going to get 4 and 12 plus, and then 3 times negative 4 is negative 12. 3 times 4 is positive 12. Okay, so it's like one extra step. like I said, you're kind of like distributing that 2 and that 3. Okay, then we combine them together. So 4 plus negative 12 gives us negative 8, and 12 plus 12 is 24. Okay, and that's easy. Okay. So we're going to kind of pull all the stuff together here now that we just learned. So here's the example. It's going to say find the resultant and then its magnitude and direction angle. And here are your vectors. So we're going to do negative 5 comma 4 and negative 2, negative 3. So to find the resultant remember means add. So you're going to say negative 5 comma 4 plus negative 2, negative 3. Okay, and that's, again, really easy. Negative 5 minus 2 is negative 7, and 4 minus 3 is 1. Okay, so that's the first part. There you go. That's the resultant. Okay, and the rest of it's really easy, what we just did before. So the magnitude, remember, if we call it vector u, doesn't really matter. It's just going to be the square root of 7 squared plus 1 squared. So 49 plus 1 square root of 50, which is 5 root 2. Okay, again, most of the time I'm going to ask you for the magnitude. It's going to be an exact answer. Okay, so now we need to find our direction angles. So we're going to do tangent of theta prime, okay, which is, of course, related to Optimus Prime or Amazon.com Prime. And we have, of course, is y over x, and we're using positive values. So it's 1 over 7. And we do inverse tangent, and we get theta prime is equal to 8.13 degrees. And then you say, well, where are we located? Negative 7, 1 is in the second quadrant. So we're going to say 180 minus 8.13 degrees, which gives us 171.87 degrees. Okay, and that is our angle. All right, cool. So it's really pretty easy to do that. So let's do. I want to do a few more problems here, math fans. And the directions for these next problems are, it's going to say find the vector given its magnitude and direction angle. And basically what we're doing here, and we've done this before, it's basically we're kind of working backwards. So before I gave you the vector and you found the magnitude and direction angle, now I'm giving you the magnitude and direction angle and you're finding the vector. And truly what you're doing when you're finding the vector, you're finding x, y. So all you're doing here is you're finding your x and y components. That's all you're doing. So it's like your vertical and horizontal components. Okay? So I got 3 examples for you. If I said, we'll call it vector A, good Canadian vector, equals 5 root 2, and theta is 45 degrees. And these are all going to be exact answer problems. Okay, so I would think the best thing to do here, math fans, is you want to sketch it because you want to be able to draw your nice little friendly triangle here. So it's 45 degrees, and the hypotenuse is 5 root 2. Well, you guys should know if that's 5 root 2, these other guys right across from the 90 is x root 2. These are 5 and 5. And they're both positive because they're in the first quadrant. So your answer to this problem is 5 comma 5. Pretty easy, right? Okay, so next example, magnitude of A is 4, and theta is 150 degrees. So let's make our sketch here again. So 150 degrees puts us over here, right? 150, but then the reference angle. Remember, you always need the reference angle inside the triangle to help you out, right? Do you guys agree it's 30 degrees? 180 minus 150. And then this is 4 here. Remember across, you got to know, remember your triangles. Across from the 90 is 2x. So across from the 30 is half of that, just x. So this is going to be a 2. And then across from the 60, people born in the 60s are radical, so it's 2 root 3. And of course, this one's negative, and that one's positive. So that's your answer, negative 2 root 3, comma 2. Okay, let's just kind of move down a little bit more. And I lied, I said we had 3 examples. I actually have 4 for you. So A is 10, magnitude of A is 10, theta is 300 degrees. Ooh, that's a hot day. And so you make a quick sketch here. We're doing this quadrant right here. And of course, our reference angle is 360 minus 300, which is 60 degrees. And this is 10 here. And so across from the 90 is 10. So across from the 30, which is down below here, is half that, or 5. And then this is going to be 5 root 3. And of course, this one's negative. So my answer for this one is 5 comma negative 5 root 3. Okay, and one last one here. The magnitude of A is 105. Ooh, we like 105. And theta is 90 degrees. So what's my reference angle? Well, there really isn't a reference angle, right? It's a quadrantal. We know we're up here. So think about it. What is that coordinate? What's that vector? Well, isn't it 0 in the x direction and 105 in the y direction? So isn't that going to be 0 comma 105? Does that make sense? And like this one over here, if it was 180 degrees, it'd be negative 105 comma 0. You know, here it'd be 0 comma negative 105. And of course, if it was in this spot here, it'd be 105 comma 0. It's just like an xy coordinate. That's all it is. Okay, that's why it's pretty easy. Okay, math fans, so the last problem we're going to do is we're going to kind of combine some of the things that we've done already using scalar multiplication and finding the direction angle. So here's our problem. It's going to say find the direction angle of the vector. So here it is, a little scalar multiplication. It's going to say 2 times negative 3 comma 4 minus 3 times 4 negative 1. Okay, so really it's pretty easy. What you're going to do is basically just multiply these out, combine them together, and then find the direction angle. Okay, so let's distribute this guy here. It's going to be negative 6 comma 8. And then I like to distribute the negative 3 just to have a positive over. So if I distribute the negative 3 times 4, so it's going to be a plus here. It's going to be negative 12, and negative 3 times negative 1 is positive 3. Okay, and it's just kind of nice having that plus there. So then when I combine them together, I get negative 6 minus 12 is negative 18, and 8 plus 3 is 11. So that's my resultant vector by multiplying that all out. Okay, and then of course I want to get my direction angle. So tangent of theta prime, we're going to use positive values. So it's of course the yax, 11 over 18. And I do inverse tangent of that, and I get 31 degrees. Now, of course, please don't put that answer. If you put 31 degrees, you know you're going to lose 1 point because that is your reference angle, and you have to recognize that negative 1811 is somewhere in the second quadrant. So what are you going to do? You're going to say theta is equal to 180 minus 31 degrees. And so we get 149 degrees for theta. Okay? So again, just, this is a little bit of everything that we learned here just to get your final answer for your direction angle. All right, so again, this is not a bad day here. Like I said, we're learning magnitude and direction angle and vector operations, and that's kind of this the main part of this focus here. And like I said, this last problem is just kind of combining everything together. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.